Okay, so these are going to be our notes on classification. We've been talking about how living things are organized. We've done these first few here, and we're just going to add these things at the bottom, just to help to give you a basic understanding of how scientists view living things. You know, they start with all living things and then break them down into smaller groups. So let me do this really quick. Okay, so if we look at these, let's get a pen here, and we have categories. So we have the three broad categories of domain, and if you remember these, we can actually even change this here a little bit. Eukarya, and we have these three basic ones. We have eukarya, which are the organisms we usually think of when we think of living things, like plants, animals, fungi, and protista, and they have lots of organelles that we've studied, and kind of like they have cells that we kind of recognize and so on. And usually when we think of a living thing, we think of eukarya, especially because we're in it. We're in this domain right here. Okay, so humans, we'll put that in there. And then we talked about archaea, and there could even be an A in there. And eubacteria, or even just bacteria. These are just two other domains, and they used to just have the bacteria one, but they've realized over time that these guys are really different. They live in extreme environments, and they have a different cell wall construction, and you could even argue maybe they're not really a different domain, but just for categories, putting in a different category and help making it easier to communicate, they have decided to put these in their own. Okay, now you might have heard this term Monera. Just be aware that they used to call this whole thing together, archaea and bacteria, Monera. So since they've changed that, you might hear them refer to either one of these, and more specifically eubacteria, as Monera. So if you hear that, don't be surprised, but it's probably not going to be this one, but it will be eubacteria they're talking about if you hear the term Monera. And then we talked about, also you've seen this before, kingdoms. There's 6 of them. When I was in school there was only 5, and that's because of this added archaea. And a lot of the reason why they now have this extra kingdom, this extra Monera, is because of molecular science. And they kind of looked at the DNA. If I draw a little DNA over here, they now see that there's some differences in DNA, and also through the advances in science, they've been able to see that the cell walls are different. So as a result, it's ended up in a new kingdom, archaea, or archaebacteria. So, and these are the eukarya, plants, animals, protista, and fungi. These all go with that one. Okay, so, and really the one we're going to deal with is this one when we come back. So when we come back from break, we're going to be looking at these guys, and really these guys have 2 groups, the inverts, no backbone, lots of different characteristics, and then the vertebrates, and we're going to start with these guys when we come back, the invertebrates. And if you've watched the video that I assigned on the 2 domains, you'll see that it kind of goes into some of these invert groups. So if we continue, so if we look at classification, it's just like anything in science, they try to break it into more and more defining groups. So you start off with all living things, then you have 3 domains, 6 kingdoms, and then you go to the next group, phylum. So the numbers will go up. So there'll be more phylums, and then we break the phylums into classes. There'll be more of them. Okay, but as these groups grow, the organisms in them decrease. So what we're going to kind of, let me erase that there. When we start looking at each one of these organisms, we're going to look at, well, what's its phylum? What's its class, its order, its family, genus, and species? The ones that really define it our genus and species. So this is one. It's going to be one species that we look at any organism, whether it's a grasshopper, whether it's a zebra, whatever it is, there's a species for it, and there's only one. Okay, we started with all living things at the beginning, and then went to domains, just 3, and there's lots of organisms in those 3, and then we get down to the end with a species, and there's lots of species, over 1 million, but there's only one thing in that. Okay, so you may ask yourself, why add all this extra complexity to it? Well, the main reason is to help organize and to better understand how these things are related to each other. And some would argue that these similarities are due to a common ancestor. Now that's something, I'm not sure it's proven. Some people, swear by it. Others, I think, maybe not so. Maybe some make more sense, some not so much. This really depends on your idea of evolution and the rise of organisms. Okay, so many look at this grouping as common ancestors, and they look at similarities between organisms. But also you can look at this another way, is to realize that things look alike. So you have, like, for instance, you have a fox, you have a dog, you have a coyote. I'll just give you a few more here. You have a wolf. And even in Australia, you have a dingo. And then in Africa, we won't put it here. Oh, we'll put it here. You have a wild dog. And even if we wanted to, we could add a hyena. Lots of different things. These are all very similar to each other. If you looked at them, you would think they have a lot of traits that are the same. Okay, and that's how kind of our brain works. We try to put things into groups. It's no wonder that scientists have done this. Now, whether let me stop doing that. Okay, whether these things one rose from the other is really, I'm not sure it's a question that science can even answer. They attempt to answer it and help us better understand things, but in the end it comes down to, beliefs. So don't get too caught up in this common ancestor thing. It's really a big idea in science, but in the end it's not as important to understand as to understand that they organize these things with similarities, that they look alike. So fox and dog and coyote and wolf and dingo and wild dog and perhaps hyena, I can't remember if it's in this group, but they're similar. And so they'll all be found in the same group. Maybe the same class or the same order, but then as they're a little bit different, they break into a different family or genus or species. Okay, definitely a species. Because a dog and a dingo, or a dog and a coyote, they're not the same species. They may be the same genus, but not the same species. Okay, so, but they organize it this way to show similarities. Now they've also analyzed the DNA of each one of these things, and they see that they're very similar. Okay, so if we draw another DNA here, okay, it's not a very good one, but I'm still practicing using this, so please forgive me. But okay, so there's DNA. Now, they also find that the DNA is similar, okay? And some would even argue, well, that means they're related. But I don't know, because, that's, again, a question you have to ask yourself, because if something looks similar, shouldn't the DNA that makes those things be similar? Okay, and again, that's something to think about, I guess. So similarities that used to be just external, but now they're looking at DNA and all kinds of other things. So it's kind of cool. So, and the father of this whole system here, kingdom, phylum, class, order, or class, order, family, genus, species, is a guy named Carl Linné. And he was a botanist, looked at plants originally. He realized that the names were really complex and really hard for scientists to communicate. So he came up with this Linnaean classification system. It uses Latin. The reason it uses Latin is because everybody can understand Latin. It's a pretty language that most people, it's a base language that many of our words today come from Latin. And but it's not being used anymore, so the meaning of words will not change. And he came up with binomial nomenclature. He would use Latin. Write this down. It's hard to do. Still learning how to do it. So in the end, what this means is that each organism has a unique genus and species name. Okay, now they might have the same genus, but their species is different. Okay, there are no species or organisms that are different that have the same genus and species. They're all different, and there's just two names. It used to be much more complex, and he used Latin. The names mean something, when you look at Canis, canines, and many of the names mean something and have a real definite description of what's going on with the organism. Okay, and like I said, each organism has a unique genus and species name. So I'm going to erase some stuff here, finish this up. And as I said, there's millions of species, and the genetic similarities have recently become more important. They have now kind of split some of these up, changed some of where they put things based on the DNA. Now, whether that's whether that's a good idea or not, probably is a good idea. That's just another way to look at how things are constructed. But let's go back, making a little DNA there. Okay, and it's really with the understanding of DNA, it's really a common thing for scientists to really look at that now, the DNA, and see, well, we had these grouped according to what they look like. There's morphology, but how does that match up with the DNA? Many of them, they're finding they do, which makes sense, because this is what makes the proteins which make the organism, it's the blueprint, makes the organism look like what it does. So it's what should be expected, that if two organisms that are not the same species but have similar characteristics, it would be expected that they look the same. So that's become more important recently. And then dichotomous keys, we're kind of practicing with them in class. Make sure you know how to use them. Just helps you, if you have an organism, two organisms that look similar but they're not the same organism, how do you identify it? And scientists have designed dichotomous keys to help do that. Okay, so that is it. Make sure you annotate these and turn them in, and good job.